All right, so this is the second video for Algebra 1A, or the second assignment, April 2nd. Basically, I'm going to go through the first problems of the first two videos, and you can check your answers. When you submit those, I'm checking to make sure you're on the right track and that you've answered the right problems and kind of that you took notes. As far as individually grading them on that document, it's not going to be able to hand them back to you and grade them. And plus two, time-wise, there's no possible way to really do that. But I just kind of make sure you're on the right track. This will be your way to check your answers and know that you did them correctly as you go on. You get the daily participation, you get the attendance, and then from there, then you're going to be grading it. So keep your work in your notes. That way you can go through and have the correct answers on the next videos, these here, and you can check them and keep notes that way. So I'm going to start with the PEMDAS problems that I had you do on that very first video. We had 29 plus 8 divided by 2 plus 5 minus 9. And my markers, they're holding out, but I get out of self-quarantine this Friday, so that's going to be one of the first things I go get is some markers, unless there was like a run on markers that I didn't know about. But basically, this problem here, you got to follow PEMDAS. So the first thing you have to do on this problem is the division. Okay. So all I did was the 8 divided by 2. Now I'm doing these step by step so that you can see each step that I'm doing. You're going to see later where you can maybe do a couple steps at once if you wanted to, if you're already at that stage. But for right now, we're just kind of going step by step. I did the division first. And now I can go left to right because it's all addition and subtraction left. So 29 plus 4 is 33, plus 5 is 38, minus 9 is 29. Okay, so at the end I just 33, 38, minus 9 is 29. Okay, so that's the answer to the first problem. All right, and if you need to stop and pause it to check and go through it, do that. Second problem is 12 divided by 6 plus 3 times 2 plus 5 minus 2 divided by 2. Okay, so this one we have a parentheses, so we have to deal with that first. So that's the first thing that we're going to do is down here in the parentheses. This is where I was talking about. If you go ahead and do the division and multiplication before you get to the parentheses, because you know once you get there and get done that you can do that, that's fine. But for right now, I'm just going to rewrite everything and show you that in here, I'm going to do my division first. So 2 divided by 2 is 1. So 5 minus 1. Okay? Then once again, you can rewrite. And 5 minus 1 is 4. Now there's nothing left to do in that parentheses. What I was meaning by if you do the division and the multiplication, you're still going to end up with now you're going to get 2 plus 6. So I did my division, my multiplication. What I'm not doing is the addition. I'm waiting on that because that you have to do your division and multiplication before you do your addition. Plus 4. So even if you had done those as you're going along, that's fine, but that's going step by step. Now you just do 2 plus 6 is 8, plus 4 is 12. Okay? All right. Third one. You've got a bracket. So you've got a grouping inside of a grouping. 12 divided by 5 plus 1 and minus 8. Okay, so you work your way to the innermost grouping symbol first. So 12 divided by 6, 5 plus 1 is 6. Okay, and now you're inside one parentheses. You're done inside this one. There's nothing left to do. So you can go ahead and do your division. 12 divided by 6 is 2. Okay, and 2 minus 8 is negative 6. Okay. So you do 12 divided by 6 is 2, minus 8, 2 minus 8 is negative 6. You had 2 positive, you went 8 in the negative direction, so that puts you at negative 6 there. All right, number 4, there's some parentheses and exponents. Three squared plus 7 minus 4 divided by 2. Okay, so inside the parentheses you have to do your exponent first. This is not 3 times 2. I did notice that some on the exponents are still doing 3 times 2. On a couple of them I saw that. Make sure you're doing 3 times itself. And I know when you're hearing that, you're like, oh, that's right. And you're throwing your pencil at the screen or something. Don't do that because, you know, don't want you to hurt your screen or your pencil. But basically, 3 squared is 9 plus 7 minus 4 divided by 2. 9 plus 7 is 16. And then 16 minus, you're going to go ahead and do your division, is 2. 4 divided by 2 is 2. So 16 minus 2 is 14. Okay? So you did 16, even if you did 16 minus 4 divided by 2 and then did 16 minus 2, that's going step by step. 16 minus 2 is 14. All right, last one. Was 3 minus 2, and then you cube that, divided by 1, plus 5 squared. Okay, so this one, the exponent is outside the parentheses, so you have to do parentheses first, P-E-M-D-A-S. So the parentheses first is 1, okay. 1 cubed is 1 times 1 times 1, which is 1. Divided by 1 plus 5 squared. Now you can go ahead and do this exponent if you wanted to. Now this is, I saw some put 10, that's 5 times 5, which is 25. Okay, 1 divided by 1 then is 1. And 1 plus 25 is 26. Alright? So that is the PEMDAS ones. It gives you a little overview of all of them. Like I said, we use PEMDAS as we go on. All the problems that you do eventually when you're working and doing solutions and going through and combining like terms, doing all that, you have to go in the order of PEMDAS. The next assignment I had you do was combining like terms. I'm going to give this red pen a break for just a second. This is my my trusty one here at the end is this red one. The black one, we'll see what juice it's got left. 3x, oh, look at that. Giving it a rest does help. Okay, so this was the first one that I had you do of combining like terms. So you can combine the x's. 3x minus 5x is negative 2x. Okay, and then 2y plus 7y is a positive 9y. You cannot combine those together because one has an x and one has a y. And that's the most common mistake I see students make, especially when we get towards the end of the class and the finals were coming up. They go back, because we do so much then later of solving, where we're actually solving for x and y. A lot of times students think they've got to get that down lower. Well, if you can't combine them, all we're doing here is we're simplifying. We're not solving yet because there's no equal sign in this problem. So there's nothing we can set it equal to. Now later, if they tell us what x and y is, like x is 3 or y is 2, then we can plug that in and solve it. But for now, we can't, and that's where we have to leave it. Cannot combine those. Okay, so let's look at number 2. 16x squared plus 7x minus 2x cubed plus 4x squared minus 8x. Okay, so let's go through and see which ones we combine. I can combine 16x squared and 4x squared. Okay, and I can combine 7x minus 2x, which is 5x. Oh, sorry. It's the 8x. Oh, no. All right, I'm back. I took a mental break there. 7x and 8x I can combine. 7x minus 8x is negative x. And if you put negative 1x, that's fine. 7 minus 8 is negative 1. We just don't write 1 before a variable in math. There's no reason for it. If you asked, if you asked a child how many x's are up there, right here, they would say, well, there's 1x. So just by having the x there is the 1. So I get in the practice, you want to get in the practice of not writing a 1 or even a negative 1. It's just 7x minus 8x is just a negative x, okay? If you write the 1, you're not wrong. It's just not good practice. You want to make sure that you're getting used to just writing negative x. Then you've got your negative 2x cubed. Now, I want to point out here, because they used to teach you want to put things in descending order, like meaning you start with your x cubed and then your x squared and then your x. You don't have to do that. It does not matter what order these are in. Your answer could be written like this, just as long as you keep the signs the same, meaning this is a negative. So if you start with the 2x cubed, and then you put the x squared, and that's a positive, so it needs a plus sign since it's in the middle now, and then you end with your negative x, that's the same answer as that. I know it doesn't look the same, but it is the same answer, because no matter what order you write those in, it's the same answer. It'd be like if I wrote 8 minus 3, we know that answer comes out as 5. Well, I could rearrange those and do negative 3 and a positive 8, and it still comes out as 5. So whether you switch the order, it doesn't matter, just as long as the signs are the same. Just as long as that stays a negative, that stays a positive, and that's a negative. So either one of those is correct. This is, if you just did it like that, this is also correct. There's other ways. You could have had this go first or this go first. It doesn't matter, okay? All right. Let's do number 3. 5xy plus 3x minus 2y plus 8x minus 7y. Okay. Now the xy, because they're together, you cannot combine them with these x's or y's. If there was another xy, like a 3xy plus 3xy, you could make that 8xy, but there's not. So this one is just by itself. You can combine the 3x plus 8x, which is 11x, okay? And the negative 2y minus another 7y is negative 9y. Remember, negative and the negative, you're not multiplying them, it doesn't become positive. You are just saying you're negative 2, and you're going negative 7 even further in the hole, so you're at negative 9y. So that's the answer to this one. Can't combine any of those. All right. And then the last one. I think I ran out of room when I wrote it last time too. So it was, this is all one row. It's 5y squared plus 7x plus 4x squared plus 8x plus 2y squared minus 8 plus 4. And so it was all like the minus 8 plus 4 just kept going. So I could go through 5y squared plus 2y squared is 7y squared. Okay, 7x squared plus 4x squared is 11x squared. There is no other x, so it just stays 8x. And then negative 8 plus 4, so you're negative 8 in the hole, you're going 4 positive from there, so you're still left at negative 4. And I will suggest, for pre-algebra students that still struggle with negative numbers, Math Antics on YouTube. Another good one is Khan Academy, spelled like this. Okay. Khan Academy. If you go to, this is a website on YouTube, if you hit in Math Antics and hit integers, there's a lot of good videos on positive and negative numbers. Okay, so if you're still stuck with that, you'll want to go back through and kind of watch those so that you're not tripping up on that, because that was pre-algebra and even just introduced in Math Lab, so you want to make sure that you're going back and reviewing that if that's where you're missing some of these on those problems, okay? All right, now we're going to move into the new material. And I will say, this is going to be I guess, somewhat lengthy video, but there is only going to be one video from now on. The reason why I had to do two, because I did you guys in geometry together for that first lesson, because it was all pre-algebra review. So I split it in two because geometry's every day. Now you guys are going to be my only algebra class. So these will be longer videos because it'll be like, and I say longer, it's not going to be like a 3-hour video or something. Even an hour. They basically, though I'm covering 2 days of material for this one class. So just bear with me, and then, like I said, I'll have your assignment at the end of the video and that you can do, okay? The first thing I want to talk about, and this is also review a little bit, but it's kind of going more towards just working with algebra, okay? Oh my, spelling late at night. I always tell my geometry class I'm not an art teacher and I'm not a spelling teacher, but distribution is what we're going to look at, and we're going to apply it to what we're moving to in algebra. Distribution is multiplication. We're going to use multiplication, and if you remember, it's when you had a number outside of a parentheses and you had to distribute that throughout that parentheses. Here's why we use it. Okay, I'm going to put this up here and explain that you can use distribution here, but I prefer not to on a problem like this. You can, in fact, some schools teach it that you have to distribute right there. You do not have to distribute on a problem like this, and I'll show you why. If I was to distribute this problem, well, let's do it the way I like to do it first. If you're doing PEMDAS here, you would work inside the parentheses, and you can do 8 minus 3, and you get 8 minus 3 is 5, okay? And then all you're left to do is 2 times 5 is 10, and that's your answer. What distribution teaches you is, okay, you're going to multiply this 2 times every term in here, and then combine if you can. So let's do that. 2 times 8 is 16, and then 2 times negative 3 is negative 6, and 16 minus 6 is 10. So either way, you're going to end up with the right answer. But to me, if you can combine them first, it's just much easier to do 8 minus 3 and then just do one multiplication. For one, multiplication, especially with bigger numbers, gives students some fits sometimes. So it's just easier to combine what you can first and then do your multiplication. But what happens then, the reason why we have to do distribution, actually let me do one more to show that it doesn't matter how long the problem is, okay? Meaning now there's 3 terms in there. Well, if I combine them first and get 9 minus 3, I get 6. See how easy that was? 5 plus 4 is 9, minus 3 is 6. And then that 4 times 6 is 24. If you distribute, you're having to do 4 times 5, 4 times 4, and 4 times negative 3. And you see the numbers are getting bigger. So now you do 20 plus 16 is 36, minus 12 is 24, and you would have got to 24 that way. I just feel like if you can combine things in here, do that first, and then do your multiplication. But, like I said, we get into problems now that we can't just combine inside. We have to use distribution. Here's an example. We just covered in combining like terms that you cannot combine x minus 3. Okay, you can't just do x minus 3. You don't know what x is. This has a variable, this doesn't, so they're not like terms. You cannot combine that. So you're stuck as far as just doing like the the inside subtraction or addition that we did on the last problems. So now you are stuck having to distribute. So that's where you have to learn how to do that, because now we know we're going to multiply 5 times x, which is 5x, okay, 5 times x, and then 5 times negative 3, which is negative 15. Okay, if I can write, and I'm wasting precious marker length here. So 5 times x, 5 times negative 3 is negative 15. Okay? This is like when your pencil eraser is about to go out and you end up scraping your paper and you're like, no, just more eraser. But you've got 5x minus 15. That's where you stop. You cannot combine those. One has an x, one doesn't. But you have simplified this problem. Okay? That's simplifying it down to where now all you do is plug in what your x is when you need to, and you can solve from there. So that is why we have to distribute as we go on in algebra, is because we don't have the option of combining this. Let's do a little bit longer one, like that. Okay, 2x plus y minus 2. There's 3 terms in there. We've got one out here, and so we're going to distribute it. Okay, so 3 times 2x is 6x. Okay, 3 times y is 3y, positive, because it's a positive and positive. And 3 times negative 2 is negative 6. Then we look and say, can we combine any of these? We cannot. One's an x, one's a y, one's just a number. So that's where we stop. Okay. Now, I want to point out a term here because we're going to move in. You know, this is the basics of distribution. We actually did this in pre-algebra. We didn't get this long necessarily with it, but we did a little bit of this in pre-algebra. But I want to show here that these terms, each one of these terms, like I said, here's a term, here's a term, here's a term. Whenever you add and subtract, you are separating terms. So here, this is one term because you're multiplying. Okay, a 2x is one term. A 3 is just one term. This y is just one term. As soon as you add in like an addition and subtraction, you're separating these terms. So here's one term, okay, here's the next term, and because you're subtracting here, here's the next term. Okay, so those are each one term. Those are called monomials. Okay, monomials. And the only reason, like, you can put these, definitely want to put these in your notes, but at the same time, it's not, you're not going to have vocab necessarily, but you want to recognize when they say things like simplify this polynomial. But monomial, mono usually stands for one, okay, monochromatic, one color gets one color. Monomials means it's one term. You have what you call binomials, bi meaning two, like a bicycle has 2 wheels. So you can have binomials. So that'd be like x squared plus 3. That's a binomial because you got a term plus another term. So you got 2 terms. Okay. And then you've got trinomials. Tri meaning tricycles, 3 wheels. But we're not necessarily after monomials. We only really use this term, and that is polynomials. Poly means many. And so polynomials mean many terms. So as long as you get past one term, everything else is a polynomial, even a binomial, because it's got more than one term. It's got many terms. So polynomials are what this would be right here. This is a polynomial because it's more than one term. And the reason why we need to know this term is they're going to, I know they kind of towards the end, I end up saying, okay, remember when we covered this for the final? But basically, we are going to learn how to combine polynomials. And they'll ask you a problem like, combine this polynomial. And what we put into practice to do that is the combining of like terms. So we're going to use that knowledge and this distribution knowledge, because depending on if there's numbers to distribute, we have to do that as well. So let me put an example of what I'm talking about. Okay? We're going to call this combining polynomials, or even if you say adding and subtracting polynomials. Okay, so we're going to highlight this as polynomials. So I'm going to put one polynomial up there first. 7x squared plus 4x. And I want to point out this was a monomial. As soon as we had an addition sign and put another monomial, now it's a binomial. So it falls in that polynomial category. And let's go ahead and add another monomial. So now it's trinomial, but it falls into that category. Then I'm going to put in another polynomial, and it's got a distribution to it. So what we have to do is not only are we going to have to distribute right here, but when we're all done, we're going to have to go through and combine like terms. And so that's what we're doing when we're doing polynomials and adding and subtracting them. So first off, I want to look, is there anything in here that we can combine? And this is where I miss being in class, because I would just, I would just listen, and now all I hear is silence, and it's sad. But basically, what we have here is nothing that we combine, so there's no reason for these parentheses. There's nothing to distribute here. There's not a number or a negative or anything like that to distribute. So we can go ahead and take off those parentheses. There's nothing there to do with them, okay? Now this one we can distribute. So we're going to take a positive 2 and distribute it out throughout here. 2 times 9x squared is a positive 18x squared. Okay, 2 times 9. And then 2 times negative 3x is negative 6x, because I did 2 times negative 3. And then 2 times 5 is 10. Okay, 2 times 5 is a positive 10. Okay, so now we're going to combine all the terms. Now we've just got like a really long problem from combining like terms. So we're going to look through and see what we combine. 7x squared and 18x squared is going to give me 25x squared. Okay, so 7x squared plus 18x squared. 4x minus 6x. So 4 minus 6 is negative 2x. And then negative 3 plus 10 is going to be a positive 7. Negative 3 plus 10 is positive 7. And so that's every term. And I cross them off. Remember, I'm bad to forget where I left off and everything. That means I covered every term. Then I check one more time to make sure there's nothing else to combine. There's not. This has a square. This doesn't. This doesn't even have a variable. So that's where we stop with that. So just to show you, this was a polynomial. And then we had another polynomial, and we had to distribute that. Then we could combine the like terms. Now we're not solving, we're just simplifying. There's no equal sign yet, so we're not solving yet. Okay? Now let's do one like this. I'm actually going to put 2 problems up there together, because I want to highlight the differences. Okay, so here's one of them. Let me get this. Okay, there's the first problem that I'm going to show you how to do. And this is the second one. And I'm putting them back to back to just show there's one thing that's different, and it causes quite a bit of difference though. Okay, so first off I want to point out this is a polynomial and this is a polynomial. So they fall into this category, so is this and so is this. The main difference is this plus and this minus. Okay, this one's adding them together and this one's subtracting them. So I'm going to do this one first. These are actually a little easier. This one I usually see more mistakes when they're subtracting, because there's just one main rule you got to remember when you start. But basically, first off, I also want to point out right now we don't really see any distribution. There's no numbers to distribute, but you're going to see that we actually do distribute something here. But first off, once again, nothing to combine in here. We're going to take it out of the parentheses and just have it ready. Same thing with this. There's no number to distribute. There's nothing to combine. So we're going to take it out of the parentheses. So far, they're done exactly the same way. But now, what we have to look at is there's not a number right here like a 2 to multiply by. But there is this plus sign. And so it's like we're taking one of these each and adding them. So it's like we're distributing a 1, a positive 1 throughout here. Okay, and all that means is if you're taking 1 times anything, it stays the same. If it's positive, it stays positive. If it's negative, it stays negative. Because 1 times 5x cubed is a positive 5x cubed. It stays the same. And then 1 times negative 3x stays a negative 3x. And then 1 times negative 8 stays a negative 8. Okay? It was just like taking a 1 and keeping everything the same. I always tell students, I don't even really treat these like distribution. I've done so many of them that now I just know if it's a plus sign, all my signs stay the same. That stays a positive, that stays a negative, that stays a negative. Down here, it's totally different. This, just like we took a 1 and distributed it throughout here, this would be like taking a negative 1. Because you got to remember, you're doing 7x squared minus 2x squared, but you're also doing this x here minus this positive, and a minus plus becomes minus. So it's like we're taking a negative 1 and distributing it throughout here. And so the main difference is every sign changes. If this was positive, it now becomes negative. And this is not this is negative 1 times this, and so this now becomes a negative 2x squared. Negative 1 times positive 5x becomes negative 5x. And negative times negative 3 becomes a positive 3. And so when I'm teaching this as we go on, I always try to remind, hey, just remember if it's plus, everything stays the same. Positive, negative, negative. If it's minus, you change every sign. That's a negative, that's a negative, that's a positive. Okay. Now all we have left, and I'll go ahead and do this in red because we got a lot of writing up there now. It's going to look like all one problem. But now I go through and combine like terms. Okay, 2x cubed plus 5x cubed is 7x cubed. 5x minus 3x is 2x, so it's plus 2x. And negative 7 minus another 8 is negative 15. You were negative 7 in the hole, you went 8 more in the hole, so now you're at negative 15. None of these you can combine, so that's the answer to this one. This one, you just go through, do the same thing. 7x squared minus 5x squared is 5x squared. negative 3x minus 5x is negative 8x. So minus 8x. And 8 plus 3 is positive 11. So 5x squared minus 8x plus 11. So that is how you combine polynomials, the main difference being the plus and the minus, okay? And so, like I said, you may need to go back and rewatch it a couple times to slow it down and to follow through with that if you need to, but that's the main thing with polynomials there. Now, the next thing to kind of add on to that, it's not a new, like a totally new topic, but so far those were all adding in and subtracting. Well, what happens when you're I have to, and this goes back to pre-algebra, but it's a little bit of review and now putting it in this setting. Well, what happens when you're multiplying variables times each other and multiplying things with exponents? What happens? So, like, you know, when we were distributing, all the distribution ones I had was something like this, okay, to where you were just multiplying a number times these things, and we got 6x plus 8, because 6x and then 2 times 4 is 8. But what happens when you get a letter times another letter, like y times y? Well, remember what anything times itself becomes squared. So y times y is y squared, okay? And so we got to keep that in mind when you're multiplying. Do they have letters that they're multiplying times each other? And so we're going to look at a few more examples of that. What if I have, now this was an example of y to the first times y to the first, so we have y to the squared. But what happens when you have like y to the third times y squared? So y to the third times y squared. Well, the shortcut, so going back to pre-algebra, and I know some of you guys in algebra may have not had pre-algebra, so it's, you know, seeing this maybe for the first time in a really long time. But the shortcut is that you just keep the base the same, the y, and then you add the exponents. But I promise you, when you start using shortcuts and rules and you haven't done them in a while, it's like, do I add those? Do I multiply them? What? I don't remember. Well, an easy way to remember this is break this down. What is y cubed? Y cubed is y times y times y, right? That's what y cubed means, y times y times y. And then you're multiplying that times y squared, which is y times y. That's what y squared is. Well, what are you left with at that point? 1, 2, 3, 4, 5. You're left with y to the 1, 2, 3, 4, fifth power. So if you forget, just remember you can always separate that out and kind of see it out in the open and remember what it is. Let's do another example of that. So 2a to the fourth times 3a cubed. Now I've put in numbers with my variables and my exponents, okay? But it's all multiplication, so no more are we confined into the combining of like terms, because combining of like terms was only when you're adding or subtracting. When you're multiplying, it doesn't, you can multiply anything like that. So we're not confined anymore to these having to, if this was plus, let me show you, if this was plus, we're stuck. We can't add an a to the fourth plus an a cubed. But we're not adding or subtracting, we're multiplying. And so in that case, it's like we're just making one long multiplication problem and doing 2 times a times a times a times a, that's a to the fourth. And then multiplying that also times 3 times a times a times a. Okay? So what we have is you can multiply the numbers and get 6, and then there's 1, 2, 3, 4, 5, 6, 7 a's. And so the shortcut would have been to multiply the 6 and then keep the base the same and add the exponents, 6a to the 7th. All right? So let's put that with what we were just doing, though, so that you can see it in action in a problem and say, okay, let's do a distribution problem that now has letters in both of them. So let's do 2g cubed 3g squared plus 7g to the fourth. Now first off, and I keep reminding to, go back, look over your notes, look over your rules, make sure you're realizing the things you can and can't do. If you want to do parentheses first, remember you cannot add, you cannot combine these because one has a squared and one has a fourth. So as far as doing anything inside here, we're stuck. But you can distribute, and you're able to multiply things because we just did that. So the shortcut, remember, is 2 times 3 is 6, and g to the third plus g to the squared is g to the fifth. Now if you need to go over here and do it the long ways for a little bit, that's fine. So 2g to the cubed times 3 times g, and get 6g to the fifth, 1, 2, 3, 4, 5, that's fine, you can do that. And kind of get into the practice of remembering what you're doing there. But that's 6g to the fifth, okay? And then when you multiply this, you're going to get 2 times 7, which is 14, and it's a positive 14, because it was a positive times a positive, and g to the 7th. Okay, that's where I paused a little bit because I'm so used to having a student, I like want them to beat me. I like wait a little bit. I'm waiting for someone to go 7th because there's always one in class 7th. And sometimes there's one that's like squared. And I'm like, wait, okay, thanks for being fast, but let's go ahead and be right as well. So here is this. Now these two I cannot combine because one's to the 5th, one's to the 7th. So that's where we stop. Okay, let's do another one of those. So x times 5x squared minus 3x is what we're going to do. Okay, can't combine those, different exponents, but you can multiply. Now, one thing, I put this one on here on purpose because I want to show you again to remind you, there's always a 1 right here. If there's not any number written there, that's 1x. How many x's are there up there? 1, so that's 1x. And then also, if it doesn't have an exponent, it's to the first power. Like anything, if you write a 7, that's to the first power. Okay? So if you've got x up there, it's to the first power. So don't forget that. There's a 1 there. Okay? And there's also a 1 here. So that means I do 1 times 5. But then I have to add the 1 to the 2, which makes it a cubed. Because remember, if you write it out, it's x times 5 times x times x. That's what x squared is. So there's 3 x's, okay? So 5x cubed, and I'll leave that 1 up there to remind us again that this is negative 3 times 1, so that's negative 3, and x squared, because you got an x to the 1 and an x to the 1, so it's x squared. Okay? All right, one more practice, and then I've got your assignment. So I haven't seen the time on this video, so hopefully I kept it under 2 hours. 2x, 5y, unless I entered some algebra realm where I was just having so much fun with math that it's like Saturday. Okay, so 2x, 5y minus x squared plus 7. So this I'm going to do 2 times 5, which is 10, x times y, which you say, wait a minute, we've not seen that yet. Well, anything times you can just write by each other, x, y, I can't add any exponents because one's an x and one's a y. So I remember when I said keep the base the same and add the exponents, well, that's when they're the same base. Well, these are different bases, so you've got to keep them separate bases. So it's xy, okay? And then 2x minus x squared is a 2 times a negative 1. There's a negative 1 there, so it's a negative 2. And then x times x squared. Add the exponents. Don't forget there's a 1 there plus a 2, so that's 3. And then 2x times 7. Now remember, you're going to do the 2 times 7. And there's no other x here, but you can't just leave that x off. It's still there. So that's what that is. Sometimes when you see them side by side, it is hard. But if you kind of go over here to the side and remember that you're doing 2x times 7, and so it'd be like even seeing it, you could even write it like this if it helps to see it. 7 times 2x is 14x. Okay, that's what you're doing. 2x times 7 is 14x. All right, so that gives you a good kind of sample. Like I say in math, they do that. It's like, hey, here's this concept. I hope you learned it. Here's 2 problems. Now we're going to totally add new wrinkles to it and everything. So hopefully I showed you enough little different examples there that you can go back through and check. I'm going to go ahead and write your assignment. It is going to be probably a couple boards. So what I'm going to do is show the assignment for a little bit. I'm actually going to take a photo of it and then rewrite more problems up there because you got about 11 problems. Okay, so number 1. Now all of these you are just simplifying. So I'm even going to put that up there to remind you you're not solving. You can't, there's no equal sign. So you can't get like x equals 2. Okay, so you're just simplifying these. 4 times y plus 7. Huh. Simplify must sound like Siri. My phone came on. I have to remember that. All right. So number 2 will be 3 times 2x squared minus 7x plus 4. Okay. And number 3 is 7x squared minus 3x plus 7 plus 2 times 3x squared minus 2x minus 3. So these first 2 are just distributions. This one is combining a polynomial here, adding a polynomial with a distribution part of it. And then you've got another polynomial problem, 7y cubed minus 2y plus 3 plus 2y cubed minus 7y minus 5. Okay. And this polynomial and this polynomial, remember there's a plus sign. So I'll write the next one, it's going to have a subtraction sign. So remember the rules on that. 8b to the 4th minus b. And just a reminder, the letters don't matter. It doesn't matter if I use a b or a y. All the rules stay the same. Okay? So you got a minus sign on this one. So these are the 2 problems that I told you it makes a huge difference that one's a plus and one's a minus. Okay? All right. I'm actually going to take a photo of this for those that need that. So Go ahead and erase this. You've got a few more problems I'm going to write. If you're trying to copy quickly, just pause it. Just pause it there on that screen and you can copy it. Let's see. So number 6 then is going to be y to the 5th times y cubed. Number 7 is going to be 3x squared times 4x to the 5th. Number 8 is going to be 2d to the 5th times 2d to the 3rd. Number 9 is going to be 5a times 3a squared minus 2a to the 4th. Okay. Number 10 is going to be x times 7x cubed plus 2x. Don't forget that's a 1x to the first power. And number 11, your last one, is going to be 3y times 5y minus y squared minus 3. All right, so this video will be your whole video for the assignment. You'll have one assignment. It'll be those 11 problems, and you will have until Friday night at 11:59 to turn this one in. Make sure most of you guys are doing it correctly as far as putting it on the Google Classroom, but remember, just if you send me just an email, where we're getting so many emails right now, it gets kind of lost in the shuffle, and it also will show that you're still missing it on Google. So make sure you're going onto Google and submitting your pictures there. When you click on the assignment is blank, okay? Because you know, other classes can maybe put a Google Doc and have you fill out questions or have you write an essay, and so they'll leave a space there or do something. With math, it's very hard to have any kind of Google format because there's not necessarily math problems, or even these exponents, putting those on a computer are never easy. So, you know, it's going to be a blank assignment, but then you click on that add or create, and then when you click on that, it'll give you an option to do a link, and that's where you upload your photo. And I put a video earlier on how to do that, and I showed my screen, and so if you are unsure how to do that, make sure you watch that video so it'll show you. So anyway, I hope you guys have a good weekend, and I get out of quarantine on Friday, and I'm gonna get some markers. So I'm just excited about markers. That's how I roll. Anyway, all right, thanks guys.